Alright guys, day 2 of me not there. I'll be back tomorrow. Just the meetings this week that we gotta take care of. The betterment of society. So anyway, today we're gonna multiply polynomials together. So first at the top, I'm just gonna review multiplying monomials. This is from last chapter. So first, when you're doing 3a squared times 2a to the third, we will multiply our coefficients and we add our exponents. Over here in the middle, your coefficient is -2, and then you got x to the third. Again, multiply the coefficients, so 2 times -3 times -4 is 24. And then it looks like I got 5 n's when I add my exponents. So monomial multiplication we spent an entire chapter on the last couple weeks, so you guys should be fine with that. So multiplying polynomials is what is new today, or somewhat new, because you actually know how to do all of this, because all it is distributive property. So first one, you got a monomial times a binomial. So I'm just going to distribute that 2a cubed in. So 2a cubed times 3a squared is 6a to the fifth. And 2a cubed times a is 2a to the fourth. And that's it. You end up with a fifth degree binomial. This one's very similar. We're just going to distribute the 2x in. And you just get 2x squared minus 10x, which is called a quadratic binomial. And the third one, distributing in a monomial to a trinomial, it's going to give us a trinomial. So -3n times n squared would be -3n to the third, plus, because negative times a negative is a positive, 12n squared minus 18n. So we end up with a cubic trinomial. Now, when I'm doing a binomial times a binomial, all we're going to do is treat this as distributive property. Each term in the first parenthesis needs to get distributed into the second parenthesis. So we're going to rewrite this with the first term x multiplied by x minus 2. And then this sign right here, the plus sign, that's going to go in the middle. And I'm going to be multiplying the second term 1 times that second parenthesis, x minus 2. So that first parenthesis is represented now by the outside terms, and the second parenthesis is written down twice. So now I'm just going to distribute that x in. So x times x is x squared, x times 2 is 2x, plus 1 times x is x, and then 1 times -2 is -2. So I have some like terms that combine. So I got x squared minus x minus 2. Okay. The second one, another binomial times a binomial. So the first step is I'm going to split this apart, take my first term in my first parenthesis, and I'm going to multiply that by a squared plus 3. And then the second term in the first parenthesis is a minus 1, and I'm going to distribute that into the second parenthesis. Again, so distribute. 4a times a squared is 4a to the third plus 12a minus a squared minus 3. And I do not have any like terms, so what I'm going to do is write my final answer in descending order of the powers of a. Your homework will probably tell you to write your answer in descending order of the powers of a. So since this is a cubic, we're going to put our third power first and end up with that 0 power on the end. Third one, I got a binomial times a trinomial. Ooh. So again, I'm going to take my first parenthesis and distribute that into the second parenthesis. So n times n squared minus 7n plus 4. And I'm going to add that to 2. N squared minus 7n plus 4. Again, just to reiterate, the first parenthesis is represented in front of the second parenthesis, depending on how many terms there are. So as I distribute in that n, I'm going to get n cubed minus 7n squared plus 4n plus 2n squared minus 14n plus 8. So I'm going to simplify and write this in descending order. So I got n cubed, negative 7n squared and 2n squared is going to be negative 5n squared. 4n minus 14n is minus 10n. And then I got the constant on the n plus 8. So I got a polynomial that is a cubic. That's what that ends up being. Okay. Now the last part is same thing, but they're called special products. We're going to hit more special product stuff tomorrow. But we're going to do this normal and then see if you could find a pattern on how this how we can get these quicker if we got these situations here. So I got x minus 9 times x plus 9. These are called conjugates of each other. Alright? Conjugates, the first term is going to be the same, second term is going to be opposite. So if I multiply by conjugates, the same thing's going to happen. So I'm going to put my x outside with that second. And when I distribute, I have x squared plus 9x minus 9x minus 81. So what happens here is that middle term cancels out, and you do just end up with x squared minus 81. So how can we get there? We recognize that there's conjugates. We could just go from here to here. That's the goal now. All right, we don't need to multiply it out if you know it's going to be first term squared, second term squared, and you just subtract in the middle. Make your life easy. So actually, I want to write the general term here so I can come back tomorrow and you guys are experts. So if I got something like x minus a, x plus a, I'm going to square the first term, square the second term, and I'm going to subtract. So this is a general formula if you're multiplying conjugates, which is something you're going to do a lot of. Okay, this, x plus 7 squared, this one, they are not conjugates. It's what's called a perfect square. Anytime I square something, I get the perfect square of that term. So x plus 7 squared is not bringing in that squared and bringing in that squared and going, it's x squared plus 49. It's never that. That's the cardinal sin of binomial multiplication, if there is such a thing. Don't ever do that in my presence. So think about this as x plus 7 times x plus 7. So that first term is going to be x. I'm going to multiply it by the second parenthesis, and then the second term times the second parenthesis. So distributing that, I have x squared plus 7x plus 7x plus 49. So when I combine my like terms, I just end up with x squared plus 14x plus 49. Notice that that's not x squared plus 49. So, how can we get from here to the answer quicker if we know it's a perfect square? Well, if I have something like, let's just use general terms like a plus b, and I'm squaring it. It looks like I'm going to square the first term. I'm going to square the last term, but that middle term, to get from 7 to 14, I'm doubling the 7, but I'm also doing 7 times x before I double it. So what you're going to do is you're going to double the product of the two terms inside that binomial. And this is a quick way that you can get a perfect square trinomial. That's going to help us a lot when we are working backwards next week, something called factoring. So this same thing, let's try to do this a little faster now. So this is an a minus b formula, so I bet you guys could figure this out. So I'm going to square the first term. I'm going to multiply the terms together and double it, so 2 times 5x, and then I'm going to square the last term. Now whenever I square something, I'm always going to get a positive. But the terms in the middle, when I have subtraction here, that's going to be a minus this time. So this ends up as x squared, notice how I just popped that little squared there in, x squared minus 10x plus 25. Okay. Alright, another one. What would you call this? Multiple perfect squares or a conjugate? Conjugates, good. Alright, so I'm going to take the first term and I'm going to square it. I'm going to take the second term, I'm going to square it, and I subtract in the middle. It's always subtraction when you have conjugates. So that's 4x squared minus 9y squared. Done. You don't trust me? You're always not trusting me. Well, if you don't trust me, then you put the first term, multiplying it by the second parenthesis, and then the second term multiplied by the second parenthesis. Multiply all that out, you will get what I just boxed. Here's a perfect square. So again, I'm going to square the first term. I'm going to do 2 times the product of those two terms. And then I'm going to square the final term. When it's addition, everything's addition. So I got x squared plus 16xy plus 64y squared. And one more. Looks again, we have a perfect square, this time with a subtraction in the inside. Okay. So again, let's just write it out. First term squared, minus minus. So I'm going to take 2 times the 5x times the 4y, and I'm going to add that to 4y squared. So that's 25x squared. 2 times 5 times 4 is 40, so it's 40xy, and then plus 16y squared. Great thing about these special products is that you're going to recognize if we start with what I boxed, you're going to be like, oh, 25 is a perfect square, 16 is a perfect square, 40 is twice the product of the square roots of those numbers, and you'll be like, I could rewrite this quickly like that. That, my friends, is called factoring. It's just called factoring. So, alright, so that's multiplication. So we got some practice for you. I want you to do the homework C and the practice 8.2 right now in this period, and Miss Barkalow will happily answer any of your questions. So she's an excellent multiplier. That's why I had her sub today. There isn't anyone in the department that multiplies better than Mrs. Barkalow. So use her to the greatest extent you can possibly think of here. So get to work, ask some questions, and then after this period is over, get your Math Excel for 8.2 done, and then I will see you tomorrow, pending any natural disaster. Have a good one, guys.